most people think about HPC, they think about large computers, big cabinets full of compute equipment and storage and now GPUs. But what really makes it all work is the connection between the different parts. Networking is a core ingredient for making HPC efficient and effective. Within HPC, there's a lot of uses for networking. So it's exciting for us to get involved and help build up these large HPC clusters. Well, there really are 4 applications for the networking technology within HPC. So one that people talk about quite a lot is the interconnection of nodes, the high-speed fabric. And on the highest end computers, sometimes people use InfiniBand to get the highest performance. But we find on most of the clusters, Ethernet is a good way to connect the cluster nodes together and exchange information among the nodes. But there are really 3 other applications of networking that are used in the clusters. So besides the fabric, you need an access to storage. Storage is very often Ethernet, and so you need access to move large data sets from storage into the compute cluster to compute, and then to move them back out again when the computation is done. Another use for networking is access to the users themselves. So the people that are operating on the cluster have to be able to issue commands, get the data sets, move data sets out to visualization clusters to see the 3D images of what they've computed. So that's the 3rd use. And then the 4th use is there's a management network. How do you start and stop the cluster? How do you take steps when there's a diagnostic problem, something's not working in the cluster and you have to get in and debug it. So there you have a fabric network, a storage network, a user network, and a management network. 4 different uses for Ethernet technology. IBM has made a strong commitment to networking in setting up the system networking department within IBM, and then by acquiring Blade Network Technologies, really fueling the growth, really bringing in some established networking technology and some expertise to really put IBM right square in the middle of the networking industry. There are so many very interesting industry-leading solutions in IBM, and we're working with a lot of different groups, including BlueGeneQ, to incorporate our networking technology into all the other solutions within IBM. So besides BlueGeneQ, there are systems based on the Power chip that run Unix. There are systems based on x86. We're working with all the different technology leaders within IBM to bring the technology, system network technology, into those solutions. What we're seeing is a general trend in computing in the data center that spans across both our enterprise users with general computing infrastructure as well as high-performance computing. It's a broadening out of the network. So where in the past we'd see a lot of network connections collapse on a large centralized box that's very expensive and not that really efficient at moving data between different nodes in a computer, we're seeing this same paradigm from high-performance computing spread out throughout the entire data center, which is lots and lots of compute nodes and lots of interaction between the compute nodes. So a new kind of network is needed that's much broader, uses a hierarchical approach, something we call leaf and spine, and creates a lot fatter connections between the servers. The enabling technology for that is changing the way we use networks. In the past we used spanning tree, and spanning tree is a technology that makes sure there's no loops. And the way it does that is if there's multiple paths, it cuts down all but one path. Okay, and that's exactly the opposite of what you want to do in high-performance computing. So there's a new set of technologies, including something that's coming called Trill, which allows you to have many, many paths and really broaden out the network and get much better performance across the board. It makes all the applications work better.